Okay, I'm going to make a similar diagram that we made before. And I'm going to start with the trachea. When the trachea comes here, right, it becomes bronchi. Bronchi and trachea are surrounded by hyaline cartilage. And then you're going to get bronchioles, which are surrounded by smooth muscle. And then we're going to get into the alveoli. So I'm going to make just one big alveoli, and that's going to represent the area where we have gas exchange. Okay, so let's just make a big giant one. So here's a big giant alveoli. All right. So let's do this color. Okay. So out here is our thoracic cavity. All right. So there's our thoracic cavity. And the thoracic cavity, the bottom of it is this dome-shaped muscle we call the diaphragm. Okay, so this is the thoracic cavity. Okay, so each lung sits in a cavity called the pleural cavity. That cavity is lined with membranes that are made up of simple squamous epithelia, and those are serous membranes. So, here. Okay, so if I start here, and so this is the membrane that lines the cavity. This pleural cavity here. And remember, the serous membranes are continuous. The visceral one is continuous with the parietal. I never have to pick up my pen to surround the lung part. And then it's back to there. So this one here is the parietal pleura. And this one is the visceral pleura. Okay? And of course, there is a space here that has fluid in it. So it's serous fluid, right? This is called the intrapleural space. Okay? That's all I want to tell you about that. Okay, so we need to think about the pressures that are in here, because when we talk about ventilation, ventilation is a product mainly of pressure changes. So in the alveoli, there's a pressure in here. Okay, there's air in here that is, bumping up against the walls, right? Okay, that's a pressure. So the pressure that is in here is called intrapulmonary pressure. So it's basically just alveolar pressure. is the same thing as the intrapulmonary. Okay. There's also a pressure within the interpleural space. Okay, this isn't a big space. I know I'm making it look like a huge space. It isn't a huge space. It's almost more like a potential space, really. But there is a pressure there. So that pressure there is, hitting off the walls here this way. Well, this pressure, this interpleural pressure, has to be less than intrapulmonary pressure. So let's write that down. Intrapleural pressure is always less than intrapulmonary pressure. Or alveolar pressure. If it weren't, then your alveoli would collapse. Okay? So again, that pressure is always less. Okay, so if we get a lot of air or something in the interpleural space and that pressure becomes greater, it is going to collapse your lung, your alveoli of your lung, of that side. Fortunately, the lungs are separate. So your right lung is not connected at all to your left lung. So if something happens and your right lung collapses due to that change in pressure, your other lung is fine. Okay, it does not collapse as well. So this is the anatomy of the thoracic cavity with the pressures and all of that with the alveoli and the thoracic cavity. So let's look. Before we start ventilation, we need to review some gas laws. So let's do that really quickly.